Today I'm going to be talking about modeling with linear functions. So we have two vocab words that we have to define, the line of best fit and correlation coefficient. Now, the line of best fit is if we have, let's say, a scatter plot. And if we draw our line of best fit, we try and draw our line kind of down the middle, and we have to have almost the equal amount of points above and below that line. Okay, and that's our line of best fit. Now, when we have line of best fit, we can write an equation, and this helps us predict information. But when we find the equation using a calculator, this is called linear regression. And that gives us a more precise equation for the line of best fit to determine data. Okay. Now, correlation coefficient is something that we get when we use linear regression. It'll give us the value of r, not r squared, but just the value of r. And when the value of r is close to 1, your correlation is positive. When the value of r is close to -1, your correlation is negative. And when your value of r is close to 0, you have no correlation. All right? So now first off, we need to remember how to write equations of lines before we can get into the line of best fit, okay? So first off, it says use the graph to write an equation of the line and interpret the slope. Well, what we need to write an equation is the slope and the y-intercept if we use slope-intercept form. So we need to find the slope and we need to find the y-intercept. Well, if we look at this graph, it's very easy to find the y-intercept. That's at 10 right there. And the slope is, of course, your rise over your run. Well, it's rising down 2, so it's a negative, and it's running a +4. So our slope is a -1/2. So our equation for this line is going to be y equals a -1/2 x plus 10. And if we interpret the slope, we have to think about what we're talking about here. Okay, well, this is a soap in a bottle, and the independent value is your time in days, and the dependent value is the soap in ounces. Well, if we look at the slope, we're talking about the amount of soap. Oops. Let's say the decrease of the amount of soap in the bottle over time. Okay, so the decrease of the amount of soap in the bottle over time. So that's us interpreting the slope. Let's look at the next one. This one, the y-intercept is not as easily found because it's somewhere in between your 10 and your 20, so we're going to have to do something different. And they do give us two pieces of information. They give us a point, which is 540, and they also give us the slope, which is our rise over 1, which is 10 over 2, which is 5. Now, if they give us a point and a slope, we can use point-slope formula, or point slope form. So we have y minus y sub 1 equals m times x minus x sub 1. So we can label the point x and y, and we can plug this in and solve for slope-intercept form. All right, so we can do y minus 40 equals 5 times x minus 5. Distribute. Add the 40. And our equation is going to be y equals 5x plus 15. And if we interpret the slope, this is a child's weight, okay? The independent value is the age in years, and the dependent value is the weight in pounds. So we can say the increase of a child's weight over years. Okay, so we have to be able to interpret that slope. All right, up next, it's a little different. It says determine whether the data show a linear relationship. If so, write an equation of a line of fit. Estimate y when x equals 15 and explain its meaning in the context of the situation. Now, when we have something like this, it's best to graph it to see if we can draw a line of best fit and if it does increase in a linear way. If I were to graph this, it is a linear relationship. And what I would do is when you draw the line of best fit, pick two numbers that are very, very close to the line. And if I remember, these two numbers were pretty close to the line. Now, we're not all going to get the same equation if we use different numbers, and that's fine. It's just kind of an estimate. Now, if we have 2 points, 6, 2, and 16, 15, we'll need to find the slope first to write our equation. And remember, slope is the change in y over the change in x. So we have 15 minus 2 over 16 minus 6. Okay? So we have 13 over 10. So that's our slope. And then we can use point slope form. So we can do y minus 2 equals 13 tenths x minus 6. So we have y minus 2 equals 13 tenths x minus, let's do 13 times 6, 78 tenths. And then we're going to add the 2. So that's 20 tenths. So our equation is going to be y equals 13 tenths x minus 58 tenths. Okay, so that's our first one. We wrote our equation. Now, when we estimate y when x equals 15, we can plug this into our equation. So we can plug a 15 into our x. And we can pull up our calculator and plug this into our calculator. So let's look at that equation again. So we have 13 tenths times 15 minus 58 tenths. So we can put this into our calculator. So we're going to have 13 divided by 10 times 15. And then subtract that from 58 tenths. And we get about 13.7. Okay, so our y is going to equal about 13.7. And it says explain its meaning in the context of the situation. So after 15 weeks, the plant has reached a height of 13.7 inches. Okay. Now next up, I'm going to show you how to do linear regression. Okay, and there's a couple of things that you need to do first before we can do linear regression. And the first thing is I didn't add it to this list, but you want to make sure that you're going to get your correlation coefficient, your R. And to do that, you have to push second, then 0, And then after that, you're going to plug in diagnostic on. And then push enter. And your screen will say done after that. If you do not do these steps, then you will not get the correlation coefficient, okay? So here are the steps for the linear regression. I'm going to go through these on the calculator, but you can follow through if you have this page. Okay, so we're going to look at this problem. Okay, when we look at this problem, we're going to follow through the steps. The first thing we need is our points. Okay, so let's write them down. We have 1, 4. We have 2, 5. We have 3, 4. 3, 3. 4, 2. 4, 1. And 5, 1. Okay, so we're going to use these data points when we do linear regression. All right, so by following the steps, okay, first of all, we've done our diagnostic on, so it'll give us the correlation coefficient. So our first step is to go to second stat plot and make sure our stat plot is on. Mine is already on, but if yours is off, you can just push 1 and then highlight the on and push enter, because we have to have our stat plot on to be able to do this. Our next step is to push stat 1. Okay, this gives us our list. If your list is full, you're going to have to clear it out using delete. And we're going to put in all of our x's first. So that's going to be 1, and then we push enter. 2, 3, 3, 4, 4, and 5. Okay, and I'm going to arrow over and I'm going to put in the matching y value. So that's 4, 5, 4, 3, 2, 1, 1. And so we've got that in there. Okay, and we want to make sure that our window is set appropriately. So I'm going to go to I'm just going to go to window and make sure my window is within the parameters of my numbers. Since my numbers don't get any bigger than 10, this window is fine. Next, we're going to go to stat, arrow over to calc, and if you see number 4, it says lin reg. So I'm going to push 4. Okay, and it's going to come up with a list. I'm going to push enter until it calculates for me. Okay, and now it's giving me some pieces of information. It says y equals ax plus b, and I've given you the a is -1, the b is 6. So I can write the equation y equals -x plus 6. That's our equation. And our r value, which is right here, is a -0.85. So let's write those down. So our equation is y equals a -x plus 6, and our r equals about a -0.85. Okay? Now, if we interpret the correlation coefficient, it is close to -1, so this is going to be a negative correlation. Now, if you want to see what this graph looks like, what we can do is go back to our calculator, okay, and we can plug in this equation into y equals. So we can go to y equals, I'm going to put it in red, and I'm going to plot -x plus 6, because that was our equation, okay, and I'm going to hit graph. And if you notice, it's plotted all of our points as a scatter plot, and it's drawn our line of best fit in red, so you can see what that looks like. And that's it.